reaching the end of today. And last but not least of our speakers today is going to be Steve Poole. Hello, Steve. I'm going to let him handle everything here, and I'm going to tell you a few words about him. He's a developer advocate for IBM. And what I know, or what I've read about him, is that he's been working on IBM Java since Java was less than 1. He was involved in different open source projects, including ones at Apache, Eclipse, and OpenJDK. Also a member of the Adopt OpenJDK group championing community involvement in OpenJDK. He's a regular presenter at Java 1 and other conferences on technical and software engineering topics. He's going to talk today, or the theme, the title of his speech is Java in the 21st Century. Are you thinking far enough ahead? Okay, I'm going to let him take over from here whenever he's ready. And I think we should welcome him warmly with a round of applause. Thank you.
Right. Oh, great. Excellent. Okay. Wow. What a full day. So I'm going to talk to you about this subject. It's the far future of Java, when the sun is turned into a big red ball. Well, okay, maybe not that far, but it's further than you might expect. This is me. Most of that you've just heard. Worked for IBM, done Java since it was before it was 1, which used to be a fun thing, but now was sort of getting a bit old because it's such a long time ago. Right? But I do JVMs, that's my job. I'm a developer advocate because I sort of fell into it, but I've been talking about Java and JVMs for a long time, and recently it became more my day job than writing code was, okay? When you're in the JVM space, when you're in any space where you're thinking about the future, you think about the future. You're not heads down, you're always looking at the long-term stuff. And one of the things that we know about Java is we're looking quite close. Anything we talk about the future tends to be what's happening tomorrow or next week or next year. But this is further than this, okay? This talking about how far it's going to go, about the future of Java, future of the JVM, possible futures. None of this may actually happen, but I think it'll come around something like this. But it may seem, from the title, it's about the tech. But actually it's not really about the tech. It's actually more about how we, as people who use tech, are going to find the world changes. So it's actually about how we're all going to think differently. How when the dust has settled, you'll be finding that what you do today isn't what you do tomorrow, right? Because of all these sorts of things that are coming down the road. So this talk is more about you than it is about the tech. So bear that in mind. So what are you thinking about today? Almost everybody has thoughts about the future, and you're thinking about what you're going to do when you go back to work, what you're doing next week. It's all close. You might be thinking quite positively about Java. Some of these things, you might be going, have I still got to learn new stuff in Java 8? What's happening in the next releases? What does LCS mean? There's all these things about Java that's happening now, and we're trying to figure out what it is. Do you find out about JShell? There was a talk about JShell recently. All these things. So you may be thinking about those. You may be thinking about Java like this, right? Little Java, big Java, and middle Java. You might be thinking about Java like this. You might be thinking about EE versus Spring, and the fight there. And you might be wondering, is microprofile, this new thing that's occurring, going to come in and take it? That might be what you're thinking about. You might be thinking that actually Java's old, and we're not going to use Java, and we're just going to use something else, right? The chances are, whatever you're thinking about now, okay? Now. When in fact you should be thinking wider. It's a good thing to raise your eyes and think about why things happen, right? Why is it that Oracle donated Java EE to Eclipse? Why is IBM open sourced its J9 VM? All these things, questions that you should be saying, where's it going? Because the more you think about the future, the more you start to make your own predictions, the more you take control of where you think things should be going. So let's think about what drives us. And no, it's not a big monkey. It looks much better on my screen. Right? What drives us? One word. This. Everything we do is driven by economics. One way or the other, it comes down to money. Faster, cheaper, easier, better. Whatever it is you think you see, whatever some company is doing, whatever intersected group of people are doing, it's driven by this. They have some economic situation in their head they're trying to achieve. Make more money, that's fine. Make things go faster, whatever. Save time and effort. And in the Java space, we've been driven by one sort of economic, the performance, because of this thing. This is Moore's Law, a picture of it. Moore's Law was this discovery by this nice guy called Mr. Moore, who worked out that every 18 months, the performance of your computer doubled. What he actually worked out was that in 18 months you can get twice as many transistors into the same space as you had before. So now you have twice as many transistors on your chip, so you can have more memory, you can have bigger CPUs, etc. And there was this progression, right? And this drawing was actually drawn around about 2010, I think, when the prediction was it was going to go on forever. And all that Java was being asked to do, all the VM was being asked to do, was to match that curve. Return your investment, please. Give us the best environment. And we did that. We built this really big walled garden around it. We built a place for Java applications to run that's the best than anybody else's. It is the best place to run those big applications. We have the fastest runtimes, the most scalable runtimes, the best garbage collectors, the best re-optimizing compilers. We invented, over the 20 years that we've been doing it, some of the most amazing technology ever. The best environment. Nothing beats it. But the weird thing is, we didn't do it because we thought we should do it. We did it because we were told to. Java's innovation, in fact, most innovation, comes from outside factors. So when Moore's Law stalled, about 2010, we were asked to deal with that. We didn't predict it, it just happened. And suddenly we had to deal with multi-core environments. And if you think, actually, we did that reasonably well. That wasn't actually too hard, but it wasn't our choice, it just happened, right? And then something else has come through and hit us. Oops, try that again. We achieved something really fantastic, something we've been planning, talking about for years. This thing, compute on tap. Compute on tap. How can I get my resources just by spending some money? Don't have any infrastructure, all those sorts of things. i.e. cloud. Cloud is a new thing. We all have heard about it. We're all using it, right? It's different, but it's still run by economics. Whatever you do, economics rules. And in the cloud space, it's all about compute equals money. right? Compute power in the cloud is stuff you buy, whether you buy memory or processors or bandwidth, you buy it. And what we've done now is we've made the connection between compute power and real dollars much closer than it's ever been. People can see it. Our accountants can see it. The finance guys can see it. So they now understand that things like gigabytes per hour, which is the thing that we tend to go off to the cloud and buy, is money. So when we ask to do more gigabytes per hour, we want to buy more because our application needs it. The accountants now understand specifically how much more money that's going to cost. Yeah? So effectively, as a Java developer, you're now doing this. How many people here write Java code for a living? Oh, okay, good. Some of you. Okay. So as a Java programmer, everything you now do in the cloud in terms of specifying memory usage is now going to be scrutinized, right? Because your accountants understand what that means. So if you go, I want to increase my memory, they're going to say, oh, that's another $1, another $10, $100. No, do it some other way. We've never had that sort of pressure. And you can't ignore cloud. Right? Cloud isn't going away. Cloud is here to stay. It's here to stay because what you can get in the public cloud, Amazon offers, Azure, IBM, Google, all these wonderful cloud spaces, this idea of being able to measure the economical cost of things that quickly, they want that environment. So enterprises want cloud in their data centers. They want to be able to deploy to their data centers in the same way, get the same experience. So cloud is coming to a data center near you. Now this is a slight plug for a thing that IBM provides, which is called IBM Cloud Private. And it's literally that. You can go get this now. There's a CE version. You can clone it. You can do Vagrant up. I can do it on here. 15, 20 minutes later, I have a cloud. I have a cloud running on my laptop. I can take that and put it into a data center. I can give developers a cloud experience. And it isn't like, oh, it's a cluster. No. These have nice little UIs. They give you dashboards, app stores, right? This is the experience that enterprises are after. And with that experience, the pressure on you as a developer is to realize that anything that you may have done to deploy to the cloud, you're going to be doing it again, even if you don't have a public cloud. So that gives us some challenges. Because the world of the cloud, which is coming to all of us, because of those economics, we can't do Java the way we used to. We had a structure, a shape of Java, and that doesn't work for the cloud. The cloud requires a different structure. And we don't know how to do all this, right? Cloud has just come onto the scene and we've been going, what do we do? How do we deal with this stuff? And it's a big challenge. We need to go from applications that were designed to run forever, big applications, lots of servers. We're willing to trade startup time for throughput. It was all about that economic. I can afford to spend time at the beginning to give me throughput later on because my application is going to run forever. But now we're also saying, can you add to this really a different shape? Short-lived, container-based, microservices, instant on, please, always available, multi-server, polyglot, completely different set of requirements than what we're used to. We need to move from profiles like this big one on your left with the big hump to smaller ones which don't have humps, because if you imagine that's memory that you're buying, go back to a cloud, when you buy memory on cloud, you buy it in tiers. And if you have an application that needs to go into the next tier just to get started, that big hump, You don't want to do that anymore because that's wasted memory, because once you've got the application running, you could run in a smaller tier if only you could get rid of that hump. So we need to do things like that, remove the hump. The angle of startup, the longer it takes to get to the point where your application that you've deployed is ready, the less it's able to actually respond to any workloads. So the quicker you can start it, the quicker you can get that angle up, the better. We want things like this, instant on, no peaks, up and running. We want it now. It's a big challenge, right? This is our current challenge. And we need it now because we've not been very good about innovating in the past. So it's not only about us changing the problems, it's all changing and dealing with these challenges. It's about showing that we're doing so. So that's one of the reasons why you're seeing so much in the change in the ecosystems. IBM's contributing code, Oracle's moving code around. We're trying to position ourselves so that we can increase the innovation. We can share more, right? Give options for everybody to contribute. IBM did Eclipse OpenJ9, we open sourced our Liberty server. There's all sorts of stuff happening to try and build a new shape of ecosystem, right? Get things out the door faster. Whatever technologies are in the pipe, right? So modularity took 10 years to get out. Streams took 5. And this thing is, the enormous amounts of technical effort, you can't fault anybody for the effort, but we can fault ourselves for the fact it took us a long time to release them, which is why we have these new cadences releases to try and get the innovation out faster, right? So new platforms to do, pick your app server, pick your version of VMs, right? Build new technologies. There's new stuff coming. We want to get it out. Some of it's already here. Cloud says, smaller footprints, please. Right? And some of this we've already got. So here's a really simple thing. You can go do it yourself. So ngrinder.jar happens to be a web application. It's pretty big, which is why we picked it. It's a way of, we want to measure how quickly things start. We'd like to measure how much memory they take. So pick something. So if I run that and I measure it, hotspot JDK8, almost 600 meg to run this thing. OpenJ9, 359, a lot less. Right. And here's more. Hotspot JDK8, 57. Hotspot JDK9, we managed to get it down to 340. But J9 got down to 240. 240 from 570 by going to a new release and choosing a different JVM. The stuff is coming. Really cool stuff. The funny thing is, that's not really what this talk is about. That's now. Really good stuff, new innovation. We're changing the way we're getting code, the way we're delivering to give you that in your hands. We know what to do in this space. That's not the big challenge. The big challenge is the other stuff. So I'm in datafication. So I've seen some data analytics tools here. How many people here do machine learning, data analytics? Good. Okay, so I can say anything. Okay. So the new world, about these things. Cool, new stuff. Still driven by economics, remember? It's different. The new problems we're challenging again are not ones that fit in our brain, right? They're about things that we find really difficult to visualize, right? But they're changing the world. The talk before this, right? AI involved in your emails and things. It's there, and what it does and how it does it hurts. But it's not going away. It's all about optimization. It's about how do you visualize complex things? And I really mean complex things. How do you get meaning from enormous amounts of data? These aren't things that as developers we're used to doing. That's not what we do. We write code, however you describe it, reactive, functional. We write code with a purpose, which is repeatable. We understand data in it, does something, we get the same results out. Okay? These things demand, these new technologies, new approaches aren't like that. They want us to do things that we're not good at, and it turns out that mostly our compute environments aren't good at either. So let me give you an example of the scale. So for instance, machine learning.